Hi everybody, this is Mrs. Ellsworth reporting to you from a lab that there's definitely food and drink in, but we will just ignore that. And I wanted to say hi to everybody. Kind of missing my classes, missing the students. I'm missing people. Just teasing. We're going to go over our titration lab, and in this lab what we're doing is we are going to neutralize an acid with a base. This base is inside of here. It has a known molarity, so we already know what the molarity is of that one, so we can go and calculate what the molarity is of this unknown acid that we have right here. So let's go ahead and show you what some of the chemicals are involved here. So I've got this beautiful drawing with my artistic capabilities. Oops, hold on. Okay, so in the burette, there's NaOH. It is 0.1 molarity. Okay, sodium hydroxide, the base. Then inside the Erlenmeyer flask, you'll notice that it is filled with hydrochloric acid. In fact, I'm putting 25 milliliters of hydrochloric acid. There's also an indicator in there of phenolphthalein. Okay, and I suppose I should probably do this like I would in the classroom and talk about the hydrochloric acid. Of course, is an acid, so it corrodes and it reacts with metals. And there is metals in your skin and in your mucous membranes and stuff like that because we are made of elements, and so it does sting. Okay, the sodium hydroxide that has filled this burette, it is a strong base. So it also reacts with tissue, so it's important to wear your goggles and not break everything in the process. Okay, so I've got this already filled up with the base. I had to go and rinse it with a whole bunch of distilled water first and unclog it. It always takes a little bit of time. So here is my my Erlenmeyer flask I'll be performing this procedure in, and I'm putting a spinner inside of it. Okay, and here's the 25 mils. Sometimes well, in all these times that we've done the lab, always somebody seems to forget to go and put in 2 drops of phenolphthalein, and that's a heartbreak later on because you have to start all over. So let me get that. Phenolphthalein is the active ingredient in X-Lax. You only need 2 drops of it and it works great. But you definitely don't want to get it on your hands and touch your mouth. Okay, so let me see if I got this all set up. Let's get this spinning. Oh, there we go. Okay, so hopefully you can see that. And what we want to do is that when phenolphthalein is in an acid, it's colorless. But when it gets to be a base, it is a bright pink color, and it is designated as red. It was on that one page in your book. It had such beautiful color indicators in there and such good color quality that I thought that looked pretty cool. Anyway, this is not spinning good. There we go. Anyway, so we're going to gently go and drip a whole bunch of phenolphthalein in there, and then we're going to go and calculate what the molarity is of this unknown stuff. But there's something that's very important that you got to start out with, and that is that you have to go and take your first initial reading. And I can't get up that high, so I'm going to pause it, and I'm going to get there. So I read it, and I've got 1.79 milliliters of is what the first reading is here. This burette is different. Down here is 50 milliliters, up there is 0. And so you have to read it upside down. So usually when students did this lab, that would be one of the problems that they'd be reading on the bottom side of the numbering system on here, and so they would have problems with that. So I'm going to go ahead and write that down. 1.79. Okay, and we've got 25 milliliters in there. I'll go ahead and write that down too, and we'll deal with this stuff later on. 24.0. Hey, this also is very, very precise. You read to the nearest hundredth, so that's pretty nice. Okay, so we'll go ahead and start this. We're going to start dripping it in there. And I want you to know that the person who's doing your lab is the most impatient person of doing this lab. I don't know if you can see that, but it gets a little bit of a pink color right on the top of that. I got to get that washed off. paint. I'll get that off to the side a little bit better. Okay, so when you start to get just the slightest tinge of pink, and that was also on that page in your chemistry book, when you start to get just the slightest tinge of pink, then you can stop the lab, because it is at 7 when it's just a smidge of pink. Now for a person like me who has a little bit of a color, I don't have color blindness, but I definitely have trouble seeing some colors. I have trouble seeing pink, so I've always kind of suffered a little bit with phenolphthalein as an indicator. Just the slightest smidge of pink, and it's as soon as it's pink, really pink, then you went way too far. And it takes just 1 drop. Yeah, I'm kind of impatient. It's not showing any pinkness in there at all because it is too far away from the end point. As soon as I start to see it hang around a little bit, then I slow down. And again, you have the I mean, you guys don't have experience with this, but you have definitely the problem with, if you go too fast, 1 drop is all it takes to go too far, and then you're off by 0.2 up here or more. So you have to be very patient with it, which again, I have problems with that. I had a chemistry class in analytical chemistry in college where this is all we did, 4 hours a day, and we did it 1 day a week, and it was hard for me to be patient with it. We actually had one guy in our class that would make up songs on the fly, like a lot of people are doing with this COVID-19 songs. Okay, I better start settling down. We'll just let it drip continuously just for a small amount. That thing's kind of harsh. I'm impatient again. Here we go. Ooh, I saw some pink in there. Right now at about 22. Of course, my hand puts a shadow in this thing, so I'm having trouble seeing where the end point is here. I do see a little bit of pink hanging out though, so I gotta go a little bit slower. It's kind of weird because it'll go all around the whole flask, and I don't know if you'll be able to see that, but it'll fill up the whole flask. It'll start, before it gets that far, at the end point, it'll start just kind of hanging out in the middle, and then it'll mix, it'll just go away. It just has to stay there for 5 seconds. Ooh. It's hanging around there. We're getting very close. I don't know if you can see the coloring with my web camera from my computer. It's not the very expensive computer there. It's just my own home one. But it's got to hang around for 5 seconds. Oh my goodness, it's getting close. It's exciting, everybody. Oh, it's very close, just 1 drop. When I was becoming a lab tech and I was going to school at Fergus Falls Community College, it was called back then, we actually did this kind of titration lab with finding out how much chlorine is in people's blood. And so Oh, ignore that. Ooh, one more drop, I bet. Oh, is that pink or is it not? One more drop. I bet. We'll see. Oh, that might have been too far. Okay, so that was definitely the one. And so I'm going to take a reading right now. And it is at 26.69. It's just a smidge above the line, so I'll write that down. 26.69. Huh. And I'm going to go and double check. I'm going to go and add a drop, and if it's too pink, then I know I was definitely right. Oh, see, now it's really pink. I don't know if you can see how, oh, it goes away after a little bit. It just has to stay for a second. I will give it just one more drop. I was definitely at the right spot, and I don't know if you can see it with my computer there. It definitely hangs out too long afterwards. I've got it spinning so fast. Sometimes the indicators, it gets so hard to tell. I don't know if you can tell how pink that this is or not. It's, I hope you can see it in there. Otherwise, you just got to take my word for it. I never lie to you, would I? And of course, I'll empty her out. Okay, so, you know, I realized while I got you here, and I did bring home litmus paper and pH paper too, so why don't we go ahead and look at that too. Okay, and then I'll let you go. So, here's some red litmus paper. Let me go and pause it while I get out all these pieces of paper because I take forever for my big fingers. Okay, first is the NaOH. Let me make this thing drip better. Sorry about this. Here I thought I was going to be organized now. Okay, so here's the NaOH on a base. Okay, and you can still see that it stays blue. It's actually kind of a purple color. Okay, and here it is with the red litmus paper. Ooh, that's beautiful. See how it turns dark blue right away? So it's definitely a base. Both of them are blue, the red and the blue. Okay, and let's look at the pH paper. Ooh, wow, look at that. That's simply amazing. Here's my pH guide. Okay, and so you can tell that that's at a 12. It's so dark blue. And I just touched my finger with that, and I think I'm going to go wash that real quick. Okay, so let me pause and I'll get you onto the acid here part. Okay, so here is the hydrochloric acid on the red litmus paper. I hope that you can see that they both turned that pink color there. Okay, so it's red, really that's what they call red, even though it's pink. Okay, and then we'll try it with the pH paper. Oh boy, that got a really pretty red. Okay, and so I'll compare that. You're supposed to compare it immediately with the indicator on here, and it looks like it's around a 1. So, and that's your stomach acid that's inside your stomach that's got a pH of 1. So, so now you've seen it titrated and with the different pH papers, and so that's all I got for you right now. I'll see you when I see ya.